Hello, everyone. My name is Joshua Olusegun Ajitomobi. It's my pleasure to welcome you to this tutorial on correlation and regression analysis with R software. For correlation analysis, we need two packages. We need GPLYR to manipulate the data sets. Usually, we need correlation for quantitative variables, so we need GPLYR to select the quantitative variables. Then we have SJPlots package in order to create the table for our correlation matrix and to plot the correlation matrix. We want to use a data set, employee data. So let's check the column names. So we have 10 different variables: salary, age, education, starting salary, job time, previous experience, up to dummy variable for education. Like we all know, we need to select quantitative variables. So to select the quantitative variables, that's what I call Qt data. So I have employee, select, salary, age, edu, starting salary, job time, previous experience. Those are the main quantitative variables of interest. So let's run it. So we run this, and in order to obtain our correlation matrix, the function is tab_call. This is our data set for the quantitative variables. So let's run this. So this is it here. We can change this to lowercase. So lower. So this, yeah. So you can use any of them. So to plot the correlation matrix, what we need is sjp_call. So we run this. So beautiful. So this is what is needed. Again, we may want to obtain the scatter plot matrix. With that, we need the scatter plot matrix function in car package. So we need to run library car. Then we have scatter plot matrix. Then these are our variables. So let's run this. So this is the scatter plot matrix. And we can do that by gender, if that is what we desire. So in this case, I've selected age, education, job time by gender for illustration purpose. So let's run this. So you can see the legend here, female, male. So the small circle here is for female. So the triangle for male, yeah, that is it. So, and we all know how to interpret scatter plots. So, and that will take us to simple regression analysis. Simple regression analysis. For simple regression analysis, you know that is between two variables, one dependent, another independent. Let's say that our interest is determinant of earnings, or the salary. in our situation, the most important variable here is education. So let's run salary against education. So we start by looking at it in linear form. So let's run this. And we get the summary. So let's plot the summary here. So if you look at the summary, you can see that another 1 year of education, we increase, well, this is positive and significant. We increase earnings by 3,915.8 naira. We can run a semi-log, in which case we have our salary in log form. So if that is what we desire, we call that one OLS2. So let's run this. And let's get the quick summary, OLS2. Run. So, oh, sorry, I need the summary, not just OLS2. So summary. So summary. All right. So in this case, a unit increase in the education. So 1 more year of education, we actually increase salary by 0.096%. Then we can have a kind of double log situation. So let me copy this quickly. So copy this. So let's have it here. Paste. So let me have this as OLS3. OLS3. And I have this as log of education. Sorry about that. Okay, so thank you, so right. So run. So let's get the summary. So in that wise, you can see that a 1% increase in year of education, we increase salary by 1.11%. So I think that's straightforward. And in case we want to move all the results to Microsoft Word, so we need Stargazer to do that. So run. Then let's add OLS3 here, comma. So then type HTML out. Let me add OLS reg. I call it OLS reg dot docs. Doc we actually export this to Microsoft Word directly. So let's run this. So beautiful. So it's already there. So let's yeah, I think it should be here. That's OLS reg. Sorry, let me check our working directory. So that is going to be stored in our working directory. So it's already stored in this business email analytics. All right. So I save it as olsreg.doc. So let's check, and for sure it's going to be there. OLS red. So this is it here. So open it. So here we are. So you have the full result here. That's interesting. So let's go back to our R. So the next thing is to try to perform some diagnostic test. To get a very quick diagnostic test, we need performance package. I think is the quickest I can find. So let's check. Just say check underscore model is our earliest one. So you can see, so we have linearity assumptions, which seem to be validated here. We have homogeneity of variance, which is showing us that there is no problem of heterogeneities. We have normality. We can see that the points, the dot actually fall on the line, indicating that the residual is normally distributed. And so on. Then, influential observation, we can see that all the points fall within the contour line. So in which case, we don't have problems of influential observation. So this is just what to do. And you can export this, just press here, copy to clipboard, then copy plots. So then you take it to Microsoft Word directly. So you can do that for OLS2 and OLS3. So for multiple linear regression, the procedure is the same. The only difference is we now add more variables. So now let's add the control variables. We have previous experience, job category, age, gender. So we call it 2LS3. Then here we run the log of the earnings against all the variables. That's just what we have done. Then we generate the one for Microsoft Word using Stargazer. So let's run this, and let's get the summary and check. Summary OLS 3. So let's run this. So let's go up. Yeah, if you look at the results, you can check. You can now see that the adjusted R square is 0.72. If you check the previous one where we just have education, I think it's just around 43%. But yeah, it's 72%. So which justify the need to add more variables. That's very, very important. And again, you can see many of the variables are significant, even at 5%. So we can easily explain those ones. So you can do that also for OLS4 and move the results to Microsoft Word. So, and again, like before, you can perform the diagnostic test. So that is just what we need to know concerning linear regression. So if you want to run a kind of nonlinear regression, for instance, let's start with polynomial regression. So we have poly 1 means this is still linear. So we are trying to look at the relationship between job time and age in a situation. So this is the linear form. The quadratic form, this is age plus the square of age. This is how to write it, I age square. And so this is it. Then in terms, if you want the cubic form, this is the cubic form. So, and then you can export everything using Stargazer and try to explain. And in order to make a choice, that is, we really want to determine which of the polynomial regression provides the best fit for the data set. So we have a library matrix here, and you try to get the root mean square error for the model. So here we are. Let's run for the three of them. So let's try to run the diagnostic. Okay, so here, run, here, run. So we can see that the root mean square error for the cubic function is the least. So which means it's better than linear and quadratic. So, and we can actually plot, since we know the one to use now, we can plot it. So in order to plot it, we need our ggplot2 and ggpubr. So we already know this is the formula here for the cubic function. Then you have your ggplots. This is our data set. Then aesthetics to define your x and y coordinates. Then you add the scatter plots. Then you define the regression. Already this is LM, and formula equals to formula, since we already have the formula here. Then we have to add the regression line. So regression line equation is just adding the adjusted R square and the equation label. So this is, so if we have done this correctly, let's run it and see. So beautiful. So we can see the equation here. So we can see the cubic function. So we can see the scatter plots of age and job time. So I hope this is pretty very clear. This is just what I want to show us. So we can use our own data set in order to practice this. Thank you for listening. Till we meet again. I remain yours, Joshua.